Question 1. In quantum field theory, the running of the strong coupling constant alpha s with energy scale is governed by the beta function. At one-loop order in QCD with NF quark flavors, the sign of the beta function coefficient B0 equals 11 NC2 NF/3 for NC equals 3 and NF equals 6 is Option A, positive, implying infrared slavery. Option B, negative, implying asymptotic freedom. Option C, 0, implying conformal invariance. Option D, positive, implying ultraviolet freedom. Time's up. The correct answer is B, negative, implying asymptotic freedom. Question 2. The Aharonov-Bohm effect demonstrates that a charged particle is affected by an electromagnetic potential even in a region where both E and B are zero. This effect is fundamentally a consequence of Option A, non-locality of the Schrödinger equation. Option B, the gauge invariant, non-integrable phase of the wave function. Option C, quantum tunneling through the potential barrier. Option D, the uncertainty principle applied to vector potentials. Time's up. The correct answer is B, the gauge invariant, non-integrable phase of the wave function. Question 3. In the BCS theory of superconductivity, Cooper pairs are bound together by an effective attractive interaction mediated by Option A, Magnon exchange. Option B, phonon exchange. Option C, plasmon exchange. Option D, exciton exchange. Time's up. The correct answer is B, phonon exchange. Question 4. The Lamb shift a small energy difference between the 2s/2 and 2p/2 levels of hydrogen arises primarily from Option A, spin-orbit coupling and relativistic corrections. Option B, vacuum polarization and electron self-energy, QED corrections. Option C, nuclear finite size effects. Option D, hyperfine interaction with the proton spin. Time's up. The correct answer is B, vacuum polarization and electron self-energy, QED corrections. Question 5. In general relativity, the Schwarzschild radius of a non-rotating black hole is given by Rs equals 2 gm/c superscript 2. For the Sun, m2 times 10 superscript 3 kg, Rs is approximately Option A, 3 mm. Option B, 3 m. Option C, 3 km. Option D, 3000 km. Time's up. The correct answer is C, 3 km. Question 6. The quantum Hall effect, discovered by von Klitzing in 1980, shows that the Hall conductance sigma xy is quantized in units of Option A, E/h. Option B, E superscript 2/h. Option C, 2E superscript 2/h. Option D, E superscript 2/h. Time's up. The correct answer is B, E superscript 2/h. Question 7. According to the Tolman, Oppenheimer, Fokoff, Tove equation, the maximum mass of a neutron star supported by neutron degeneracy pressure alone is approximately: Option A, 0.7 solar masses. Option B, 1.4 solar masses. Option C, 3.0 solar masses. Option D, 5.0 solar masses. Time's up. The correct answer is A, 0.7 solar masses. Question 8. In quantum chromodynamics, which phenomenon describes the confinement of quarks within hadrons, making it impossible to isolate a free quark at low energies? Option A, asymptotic freedom. Option B, color confinement via flux tube formation. Option C, spontaneous chiral symmetry breaking. Option D, Debye screening. Time's up. The correct answer is B, color confinement via flux tube formation. Question 9. The Kibble-Zurek mechanism describes the formation of topological defects during a continuous phase transition. The density of defects scales with the quench rate tau q as a power law and tau q caret, nu/1 plus z nu, where nu and z are the correlation length and dynamical critical exponents. This mechanism has been confirmed experimentally in Option A, Bose-Einstein condensates and liquid helium. Option B, only in cosmological phase transitions. Option C, only in ferromagnetic materials. Option D, only in superconductors. Time's up. The correct answer is A, Bose-Einstein condensates and liquid helium. Question 10. In the path integral formulation of quantum mechanics developed by Feynman, the transition amplitude from state x_i to x_f is expressed as a sum over all paths weighted by Option A, E caret, is/h, where s is the classical action. Option B, E caret, s/h, where s is the classical action. Option C, E caret, iht/h, where h is the Hamiltonian. Option D, the square of the classical probability amplitude. Time's up. The correct answer is A, E caret, is/h, where s is the classical action. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 11. The Unruh effect predicts that an observer undergoing constant proper acceleration in Minkowski vacuum will detect a thermal bath of particles at temperature T equals Ha/2 pi ckb. This temperature for an acceleration of g equals 9.8 m/s superscript 2 is approximately: Option A, 4 times 10 superscript 2k. Option B, 4 times 10 superscript 2 superscript 3k. Option C, 4 times 10 superscript 1k. Option D, 4 times 10k. Time's up. The correct answer is A, 4 times 10 superscript 2k. Question 12. The Berry phase, acquired by a quantum state undergoing adiabatic cyclic evolution, is a geometric phase that depends on Option A, the speed of the cyclic evolution. Option B, only the geometry of the path in parameter space. Option C, the total energy of the system. Option D, the dynamical phase accumulated during evolution. Time's up. The correct answer is B, only the geometry of the path in parameter space. Question 13. In particle physics, the CP violation observed in kaon decays is parameterized by epsilon 2.2 times 10 superscript 3. This tiny asymmetry is currently explained within the standard model by Option A, the theta term in QCD. Option B, the complex phase delta in the CKM quark mixing matrix. Option C, Majorana masses of neutrinos. Option D, spontaneous symmetry breaking of CPT invariance. Time's up. The correct answer is B, the complex phase delta in the CKM quark mixing matrix. Question 14. The Josephson effect occurs when two superconductors are separated by a thin insulating barrier. The AC Josephson effect predicts that a DC voltage V across the junction produces an oscillating current at frequency. Option A, F equals F/H. Option B, F equals 2F/H. Option C, F equals F/H. Option D, F equals 4F/H. Time's up. The correct answer is B, F equals 2F/H. Question 15. According to the ADS/CFT correspondence, a strongly coupled conformal field theory in d dimensions has a dual description as Option A, a weakly coupled gauge theory in d plus 1 dimensions. Option B, a string/gravity theory in d plus 1 dimensional anti-de Sitter space. Option C, a free quantum field theory in d-dimensional flat space. Option D, a topological field theory in d1 dimensions. Time's up. The correct answer is B, a string/gravity theory in d plus 1 dimensional anti-de Sitter space. Question 16. The fine structure constant alpha 1/137 is dimensionless and characterizes the strength of the electromagnetic interaction. Its precise value is most accurately determined experimentally from Option A, the anomalous magnetic moment of the electron, G2, measurements. Option B, the Rydberg constant derived from hydrogen spectroscopy. Option C, the quantum Hall resistance. Option D, the electron charge measured in oil drop experiments. Time's up. The correct answer is A, the anomalous magnetic moment of the electron, G2, measurements. Question 17. In non-equilibrium statistical mechanics, the fluctuation theorem, Crookes theorem, relates the probability of forward and reverse thermodynamic processes. For a process with work W performed on a system, the ratio P, W/P, W, equals Option A, E caret, W/kBt. Option B, E caret, W/kBt. Option C, E caret, delta F/kBt. Option D, E caret, W delta F/kBt. Time's up. The correct answer is A, E caret, W/kBt. Question 18. The Penrose process allows extraction of energy from a rotating, Kerr, black hole. Energy can be extracted from the Option A, event horizon by pair production. Option B, ergosphere by exploiting frame dragging. Option C, singularity via Hawking radiation. Option D, photon sphere by gravitational lensing. Time's up. The correct answer is B, ergosphere by exploiting frame dragging. Question 19. In lattice QCD calculations, the fermion doubling problem, which produces 2D spurious fermion species on a d-dimensional lattice, is avoided by using Option A, Wilson fermions, adding a Laplacian term that gives doublers large masses. Option B, naive fermions with continuum extrapolation. Option C, staggered fermions with no modifications. Option D, overlap fermions only in 1+1 dimensions. Time's up. The correct answer is A, Wilson fermions, adding a Laplacian term that gives doublers large masses. Question 20. The Kondo effect describes the anomalous increase in electrical resistance of metals at low temperature due to Option A, electron-phonon scattering enhanced at low T. Option B, magnetic impurities scattering conduction electrons via spin-flip interactions. Option C, Anderson localization of electrons. Option D, formation of charge density waves. Time's up. The correct answer is B, magnetic impurities scattering conduction electrons via spin-flip interactions. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 21. In the theory of cosmic inflation, the slow roll parameter epsilon equals /h superscript 2, being much less than 1 guarantees near exponential expansion. The tensor to scalar ratio R in primordial gravitational waves is related to epsilon by Option A, R equals 8 epsilon. Option B, R equals 1/6 epsilon. Option C, R equals 4 epsilon. Option D, R equals 2 epsilon. Time's up. The correct answer is B, R equals 1/6 epsilon. Question 22. The Wigner-Eckart theorem in quantum mechanics states that matrix elements of a tensor operator T(k_Q) between angular momentum states can be factored into Option A, a Klebsch-Gordon coefficient in a reduced matrix element independent of M, Q. Option B, a Racah coefficient in the full matrix element. Option C, the 9J symbol and the operator norm. Option D, a 3J symbol times the total angular momentum J. Time's up. The correct answer is A, a Klebsch-Gordon coefficient in a reduced matrix element independent of M, Q. Question 23. According to the Weinberg angle, weak mixing angle θ_W, the ratio of the W boson mass to the Z boson mass is Option A, mw/mz equals sin theta underscore w. Option B, mw/mz equals cos theta underscore w. Option C, mw/mz equals tan theta underscore w. Option D, mw/mz equals sin 2 theta underscore w. Time's up. The correct answer is B, mw/mz equals cos theta underscore w. Question 24. The Casimir effect, an attractive force between two unchanged arced parallel conducting plates in vacuum, arises from Option A, van der Waals forces between induced dipoles. Option B, modification of the quantum vacuum zero-point energy between the plates. Option C, thermal radiation pressure at finite temperature. Option D, electrostatic induction from external fields. Time's up. The correct answer is B, modification of the quantum vacuum zero-point energy between the plates. Question 25. In topological insulators, the Z2 topological invariant distinguishes trivial from topological phases. The surface states of a 3D strong topological insulator have a Dirac cone whose spin texture is characterized by Option A, spin parallel to momentum, helicity. Option B, spin perpendicular to momentum, spin momentum locking. Option C, randomly oriented spin with no momentum correlation. Option D, spin anti-parallel to momentum throughout the Brillouin zone. Time's up. The correct answer is B, spin perpendicular to momentum, spin momentum locking. Question 26. The hadronic vacuum polarization contribution to the anomalous magnetic moment of the muon, mu, is currently the dominant source of theoretical uncertainty. This contribution is calculated via a dispersion relation using Option A, perturbative QCD at all energies. Option B, experimental data on EE rightward arrow hadrons cross-section. Option C, lattice QCD with Wilson quarks only. Option D, the operator product expansion at low energies. Time's up. The correct answer is B, experimental data on EE rightward arrow hadrons cross-section. Question 27. The Bogoliubov transformation diagonalizes the Hamiltonian of a weakly interacting Bose gas. The resulting quasi-particles, Bogoliubov phonons, have a dispersion relation that transitions from phonon-like, omega proportionality k, at long wavelengths to Option A, Rodin-like with a local minimum at finite k. Option B, free particle-like, omega proportionality k superscript 2, at short wavelengths. Option C, constant omega, gap dispersion, at high k. Option D, logarithmic dispersion at intermediate k. Time's up. The correct answer is B, free particle-like, omega proportionality k superscript 2, at short wavelengths. Question 28. In the Regge theory of strong interactions, the angular momentum j of hadrons on a Regge trajectory is related to their mass squared m superscript 2 by Option A, j equals alpha, 0, plus alpha m superscript 2, linear Regge trajectory. Option B, j equals alpha, 0, times m superscript 2, power law trajectory. Option C, j equals alpha, 0, plus alpha log, m superscript 2, logarithmic trajectory. Option D, j equals alpha slash m superscript 2, inverse mass squared relation. Time's up. The correct answer is A, j equals alpha, 0, plus alpha m superscript 2, linear Regge trajectory. Question 29. The thermodynamic efficiency of an endo-reversible heat engine operating between temperatures Th and Tc is given by the Kurzanel-Born efficiency at maximum power output. This efficiency equals Option A, 1, Tc/Th, Carnot efficiency. Option B, 1, square root, Tc/Th. Option C, 1, Tc/Th, superscript 2. Option D, Thtc, slash, Th plus Tc. Time's up. The correct answer is B, 1, square root, Tc/Th. Question 30. Which experimental observation provided the first direct evidence for the existence of neutrino oscillations, non-zero neutrino mass, earning the 2015 Nobel Prize in Physics? Option A, detection of reactor antineutrinos at CAM-LAND. Option B, deficit of solar neutrinos, homestake, an atmospheric neutrino anomaly, supercameo-Kondo. Option C, direct measurement of neutrino mass in tritium beta decay. Option D, observation of tau neutrinos at donut. Time's up. The correct answer is B, deficit of solar neutrinos, homestake, an atmospheric neutrino anomaly, supercameo-Kondo. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 31. The dynamical Casimir effect, first observed experimentally in 2011 using a superconducting circuit, involves Option A, attraction between static conducting plates in vacuum. Option B, creation of real photons from vacuum fluctuations by a rapidly oscillating mirror. Option C, suppression of spontaneous emission near a photonic crystal. Option D, enhancement of van der Waals forces at short distances. Time's up. The correct answer is B, creation of real photons from vacuum fluctuations by a rapidly oscillating mirror. Question 32. In the theory of second-order phase transitions, the hyperscaling relation connects the critical exponents as d nu equals 2, alpha, where d is the dimensionality. This relation breaks down above the upper critical dimension because Option A, mean field exponents become exact and are independent of d. Option B, the correlation length exponent nu becomes negative. Option C, fluctuations diverge uncontrollably. Option D, the order parameter ceases to exist. Time's up. The correct answer is A, mean field exponents become exact and are independent of d. Question 33. The GW150914 event detected by LIGO in 2015. The first direct detection of gravitational waves was produced by the merger of two black holes. The peak gravitational wave strain H10 2 at Earth corresponds to a spacetime distortion of approximately what distance change over 4 km arm length? Option A, 1 atomic diameter, 10 m. Option B, 1/1000 th of a proton diameter, 10 m. Option C, 1 nuclear diameter, 10 m. Option D, 1 electron diameter, 10 m. Time's up. The correct answer is B, 1/1000 th of a proton diameter, 10 m. Question 34. The Onsager reciprocal relations in irreversible thermodynamics state that, in a system near equilibrium with multiple coupled fluxes G and forces Xj, the off-diagonal transport coefficients satisfy. Option A, L equals G, symmetric, due to microscopic time reversal symmetry. Option B, L equals G, antisymmetric, due to broken time reversal. Option C, L equals 0 for I is not equal to J, no coupling between different forces and fluxes. Option D, L equals G only for diagonal elements of the Onsager matrix. Time's up. The correct answer is A, L equals G, symmetric, due to microscopic time reversal symmetry. Question 35. In transition metal chemistry, the spectrochemical series ranks ligands by their ability to cause d orbital splitting. Which of the following is the correct order from weakest to strongest field ligand? Option A, I. Time's up. The correct answer is A, I. Question 36. The Woodward-Hoffmann rules predict the stereochemical outcome of pericyclic reactions based on orbital symmetry. For a thermal 4+2 Diels-Alder cycloaddition, the reaction proceeds via Option A, suprafacial on both components, supra-supra, thermally allowed. Option B, antherofacial on diene, suprafacial on dienophile, thermally allowed. Option C, suprafacial anterofacial, photochemically allowed. Option D, disrotatory ring closure on both components. Time's up. The correct answer is A, suprafacial on both components, supra-supra, thermally allowed. Question 37. In NMR spectroscopy, the nuclear Overhauser effect, NO, provides information about internuclear distances. The NO intensity is proportional to R, where R is the distance, and it changes sign at the correlation time tau c when omega tau c equals. Option A, 0.5. Option B, 1/√5. Option C, 1. Option D, √2. Time's up. The correct answer is B, 1/√5. Question 38. The Evans method for measuring the magnetic susceptibility of paramagnetic complexes in solution uses the shift in NMR frequency of a reference solvent signal. If the molar susceptibility Chi-m is measured, the effective magnetic moment F in Bohr magnetons is related to Chi-m by Option A, F equals square root 3 kbt chi m slash na mu b superscript 2. Option B, F equals square root 8 chi mt, in the Curie-Weiss law form. Option C, F equals 2 square root s plus 1, directly from the spin quantum number. Option D, F equals g square root j plus 1, where g is the Land g factor. Time's up. The correct answer is A, F equals square root 3 kbt chi m slash na mu b superscript 2. Question 39. The Marcus theory of electron transfer predicts that the rate constant ket depends on the reorganization energy lambda and driving force delta g degree. In the inverted region, as delta g degree increases beyond lambda. Option A, the rate increases without bound. Option B, the rate decreases, contrary to classical Arrhenius behavior. Option C, the rate becomes independent of delta g degree. Option D, quantum tunneling dominates and the rate becomes temperature independent. Time's up. The correct answer is B, the rate decreases, contrary to classical Arrhenius behavior. Question 40. Olefin metathesis recognized by the 2005 Nobel Prize in Chemistry proceeds via a 2+2 cycloaddition mechanism involving a metal-carbon intermediate. The Chauvin mechanism involves which key intermediate? Option A, a metallocyclopentane formed by 2+2 of 2 olefins. Option B, a metallocyclobutane formed from the metal carbon and the substrate olefin. Option C, a sigma bond metathesis with direct olefin exchange. Option D, an oxidative addition followed by beta hydride elimination. Time's up. The correct answer is B, a metallocyclobutane formed from the metal carbon and the substrate olefin. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 41. In X-ray crystallography, the Patterson function P, UVW, is the autocorrelation of the electron density ρ, xyz. A peak in the Patterson map at vector U corresponds to Option A, the position of an atom in the unit cell. Option B, an interatomic vector between two atoms in the structure. Option C, the phase difference between two reflections. Option D, the Fourier transform of a single reflection HKL. Time's up. The correct answer is B, an interatomic vector between two atoms in the structure. Question 42. The John-Teller theorem states that a nonlinear molecule with a degenerate electronic ground state will spontaneously distort to remove the degeneracy. For a D-copper, 2, complex in octahedral geometry, the characteristic distortion is Option A, tetrahedral distortion compressing all four equatorial bonds. Option B, tetragonal elongation along the z-axis, axial bonds lengthen. Option C, trigonal distortion with D3H symmetry. Option D, square planar compression with equal bond elongation. Time's up. The correct answer is B, tetragonal elongation along the z-axis, axial bonds lengthen. Question 43. In electrochemistry, the Butler-Volmer equation describes the current over potential relationship. At large anodic overpotentials eta RT/alpha F, the equation simplifies to the Tafel equation, eta equals A plus B log J, where the Tafel slope B equals option A, 2.303 RT/F, option B, 2.303 RT/alpha F, option C, RT/2 alpha F, option D, F/2.303 alpha RT. Time's up. The correct answer is B, 2.303 RT/alpha F. Question 44. The Fukui function f, r, in conceptual DFT describes the reactivity of a molecule toward nucleophilic or electrophilic attack. For nucleophilic attack, the Fukui function f, r, is defined as option A, the electron density of the HOMO of the neutral molecule. Option B, the change in electron density upon adding one electron, ρ, n plus 1 r, ρ, n r. Option C, the electron density of the LUMO of the neutral molecule. Option D, the change in electron density upon removing one electron, ρ, n r, ρ, n 1 r. Time's up. The correct answer is B, the change in electron density upon adding one electron, ρ, n plus 1 r, ρ, n r. Question 45. The Michaelis-Menten kinetics equation V equals V max S slash Km plus S breaks down when substrate concentrations are very high due to substrate inhibition. In the presence of competitive inhibitor I with inhibition constant K, the apparent Km becomes option A, Km, 1 plus I slash K. Option B, Km slash, 1 plus I slash K. Option C, Km plus I slash K. Option D, Km times K slash I. Time's up. The correct answer is A, Km, 1 plus I slash K. Question 46. In surface chemistry, the Brunner-Teller theory extends the Langmuir adsorption isotherm to multilayer adsorption. The linearized BET equation plots P/V, pp, versus P/P. The slope of this plot equals option A, C1, slash, Vm times C. Option B, 1 slash, Vm times C. Option C, Vm times C. Option D, C slash, Vm plus 1. Time's up. The correct answer is A, C1, slash, Vm times C. Question 47. The Ziegler-Natta catalyst system for olefin polymerization consists of a transition metal compound and an aluminum alkyl co-catalyst. The active species is a coordinatively unsaturated metal center that polymerizes olefins via a option A, radical chain mechanism. Option B, Cauchy-Arlman mechanism, coordination insertion. Option C, ionic mechanism with carbocation intermediates. Option D, concerted 2+2 cycloaddition mechanism. Time's up. The correct answer is B, Cauchy-Arlman mechanism, coordination insertion. Question 48. In photochemistry, the Jablonski diagram describes electronic transitions. Internal conversion, IC, is a non-radiative transition between option A, states of different spin multiplicity, example S1 rightward arrow T1. Option B, states of the same spin multiplicity, example S1 rightward arrow S0, with conservation of spin. Option C, the ground state and the first excited state via photon emission. Option D, vibrational levels within the same electronic state. Time's up. The correct answer is B, states of the same spin multiplicity, example S1 rightward arrow S0, with conservation of spin. Question 49. The anomeric effect in carbohydrate chemistry refers to the preference for electronegative substituents at the anomeric carbon, C1, of a pyranose ring to adopt the axial orientation. This is primarily explained by Option A, steric interactions favoring axial over equatorial positions. Option B, hyperconjugation, lone pair donation from ring oxygen into the sigma asterisk of the CO anomeric bond. Option C, electrostatic repulsion between equatorial substituents. Option D, solvent effects stabilizing the axial conformer. Time's up. The correct answer is B, hyperconjugation, lone pair donation from ring oxygen into the sigma asterisk of the CO anomeric bond. Question 50. The Hammett equation sigma-rho relationship describes the effect of meta and para substituents on the reaction rates of aromatic compounds. The reaction constant ρ for a reaction is negative when Option A, the reaction is accelerated by electron withdrawing substituents. Option B, the reaction is accelerated by electron donating substituents, positive charge builds at the reaction center. Option C, the transition state is less polar than the ground state. Option D, the reaction proceeds via a radical mechanism. Time's up. The correct answer is B, the reaction is accelerated by electron donating substituents, positive charge builds at the reaction center. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 51. In solid-state chemistry, a perovskite structure, AbO3, is stable when the Goldschmidt tolerance factor T falls in the range 0.9 to 1.0. The tolerance factor is defined as T equals Ra plus Ro, /square root 2, Rb plus Ro. A value of T significantly less than 1 leads to Option A, a cubic perovskite with ideal octahedral tilt. Option B, octahedral tilting distortions reducing symmetry, example orthorhombic. Option C, decomposition into separate AO and BO2 phases. Option D, a hexagonal perovskite polymorph. Time's up. The correct answer is B, octahedral tilting distortions reducing symmetry, example orthorhombic. Question 52. The Cope rearrangement is a 3,3 sigmatropic reaction of 1,5 dienes. The oxy-Cope variant, where a hydroxyl group is present at C3, is dramatically accelerated by 10 superscript 1-fold, when. Option A, the hydroxyl is protonated under acidic conditions. Option B, the hydroxyl is deprotonated to give an alkoxide, anionic oxycope. Option C, Lewis acid catalysis coordinates to the hydroxyl oxygen. Option D, the reaction is run in polar protic solvents. Time's up. The correct answer is B, the hydroxyl is deprotonated to give an alkoxide, anionic oxycope. Question 53. In coordination chemistry, a square planar D complex undergoes substitution primarily via an associative, A, mechanism. The trans influence refers to the ability of a ligand to weaken the bond trans to it in the ground state, and is governed primarily by Option A, the pi donating ability of the trans ligand. Option B, the sigma donating ability of the trans ligand, stronger sigma donors weaken the trans bond. Option C, the charge of the trans ligand. Option D, steric repulsion between the trans ligand and the metal. Time's up. The correct answer is B, the sigma donating ability of the trans ligand, stronger sigma donors weaken the trans bond. Question 54. The Meerwein-Ponder-Verley, MPV, reduction uses aluminum alkoxide catalysts to transfer hydride from a secondary alcohol to a ketone. The mechanism involves A. Option A, 6-membered cyclic transition state with concerted hydride transfer via a metal alkoxide intermediate. Option B, radical mechanism with single electron transfer from aluminum. Option C, ionic mechanism via aluminum enolate formation. Option D, hydride transfer through a 4-membered ring. Time's up. The correct answer is A, 6-membered cyclic transition state with concerted hydride transfer via a metal alkoxide intermediate. Question 55. In the context of crystal field theory versus ligand field theory, the Neff-Elixtic effect describes Option A, the increase in d transition energies upon going from free ion to complex. Option B, the reduction of interelectronic repulsion parameters, RACA-B, in a complex compared to the free ion. Option C, the increase in magnetic susceptibility of the complex versus the free ion. Option D, the splitting of d orbitals in a ligand field of given symmetry. Time's up. The correct answer is B, the reduction of interelectronic repulsion parameters, RACA-B, in a complex compared to the free ion. Question 56. The RRKM, Rice-Ramsperger-Castle-Marcus, theory of unimolecular reaction rates considers the density of states of the reacting molecule. The rate constant K, E, at energy E above the reaction threshold E is proportional to Option A, the density of states of the transition state divided by the total density of states of the reactant. Option B, the Boltzmann factor exp, E/kBt, multiplied by a pre-exponential factor. Option C, the number of open reaction channels times the tunneling probability. Option D, the Arrhenius activation energy divided by the vibrational frequency. Time's up. The correct answer is A, the density of states of the transition state divided by the total density of states of the reactant. Question 57. The Canning-Gold Prelog, CIP, priority rules assign R or S configuration to a stereo center. When the lowest priority group is positioned away from the viewer and the remaining three groups in decreasing priority describe a counterclockwise arc, the configuration is Option A, R, rectus. Option B, S, sinister. Option C, E, entgegen. Option D, Z, zusammen. Time's up. The correct answer is B, S, sinister. Question 58. In organocatalysis, the proline-catalyzed asymmetric aldol reaction proceeds via an enamine intermediate. The SI or rephase selectivity of nucleophilic attack is controlled by the steric shielding provided by Option A, the carboxylic acid group of proline via hydrogen bonding to the electrophile. Option B, the pyrrolidine ring blocking one face of the enamine pi system. Option C, a Zimmermann-Traxler type 6-membered transition state mediated by the carboxylate. Option D, electrostatic interactions between the proline ammonium and the substrate. Time's up. The correct answer is C, a Zimmermann-Traxler type 6-membered transition state mediated by the carboxylate. Question 59. In mass spectrometry, the McLafferty rearrangement is observed for carbonyl compounds with a gamma hydrogen. The rearrangement produces two fragments via Option A, homolytic cleavage of the alpha bond to give acylium ions. Option B, a 6-membered cyclic transition state with gamma OH transferred to the oxygen and beta cleavage. Option C, retro 2+2 cycloaddition of the carbonyl group. Option D, 1,2 hydride shift from the beta carbon to the carbonyl carbon. Time's up. The correct answer is B, a 6-membered cyclic transition state with gamma OH transferred to the oxygen and beta cleavage. Question 60. The Sharpless epoxidation of allylic alcohols uses Ti(4) tartrate complexes. The absolute configuration of the epoxide product is predicted by the Sharpless mnemonic, with plus diethyl tartrate, L- plus det. Delivery of oxygen occurs to the Option A, top face, beta face, of the allylic alcohol drawn with O at bottom right. Option B, bottom face, alpha face, of the allylic alcohol drawn with O at bottom right. Option C, reface regardless of the tartrate used. Option D, SI face regardless of the tartrate used. Time's up. The correct answer is B, bottom face, alpha face, of the allylic alcohol drawn with O at bottom right. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 61. In flash photolysis and ultra-fast spectroscopy, the transient absorption signal delta A, T, monitors excited state dynamics. A positive delta A signal at a probe wavelength arises from Option A, stimulated emission from the excited state. Option B, excited state absorption, ESA, where the excited state absorbs the probe photon. Option C, ground state bleach, GSB, where the ground state population is depleted. Option D, coherent Raman scattering from the pump beam. Time's up. The correct answer is B, excited state absorption, ESA, where the excited state absorbs the probe photon. Question 62. The concept of frustrated Lewis pairs, FLPs, pioneered by Stefan, involves sterically hindered Lewis acid-base pairs that cannot form a classical adduct. FLPs can activate small molecules like H2 heterolytically. The mechanism involves: Option A, oxidative addition of H2 to the Lewis acid metal center. Option B, concerted transfer of H and H to the Lewis base and Lewis acid respectively, without forming a Lewis adduct. Option C, radical homolysis of H2 by single electron transfer from the Lewis base. Option D, coordination of H2 as a sigma complex to the Lewis acid. Time's up. The correct answer is B, concerted transfer of H and H to the Lewis base and Lewis acid respectively, without forming a Lewis adduct. Question 63. The d-spacing in X-ray diffraction is related to the Miller indices, HKL, and lattice parameters by Bragg's law and the lattice geometry. For a cubic crystal with lattice parameter A, the d-spacing dHKL equals: Option A/square root H superscript 2 plus K superscript 2 plus L superscript 2. Option B, A times square root H superscript 2 plus K superscript 2 plus L superscript 2. Option C, A/H plus K plus L. Option D, A superscript 2 slash H superscript 2 plus K superscript 2 plus L superscript 2. Time's up. The correct answer is A/square root H superscript 2 plus K superscript 2 plus L superscript 2. Question 64. The Born-Oppenheimer approximation in molecular quantum mechanics allows separation of nuclear and electronic motion because: Option A, the nuclear kinetic energy is exactly zero in the ground state. Option B, electrons respond essentially instantaneously to nuclear motion due to the large mass ratio Mn/Me 1836. Option C, the nuclear wave function is always a delta function at the equilibrium geometry. Option D, electronic and nuclear wave functions have orthogonal symmetry species. Time's up. The correct answer is B, electrons respond essentially instantaneously to nuclear motion due to the large mass ratio Mn/Me 1836. Question 65. In heterogeneous catalysis, the Sabatier principle states that an optimal catalyst binds reactants. Option A, as strongly as possible to maximize surface coverage. Option B, neither too strongly nor too weakly. Intermediate binding energy gives a volcano plot maximum in activity. Option C, as weakly as possible to minimize activation energy for product desorption. Option D, with a binding energy exactly equal to the reaction activation energy. Time's up. The correct answer is B, neither too strongly nor too weakly. Intermediate binding energy gives a volcano plot maximum in activity. Question 66. The electrochemical series and Nernst equation predict cell potentials. For the half reaction Ox plus Ne rightward arrow red, at 25 degrees Celsius the Nernst equation gives E equals E degree, 0.05916/n, log Q. If Q equals red/ox equals 100 and N equals 2, the potential shift from E degree is: Option A, minus 59.16 MV. Option B, minus 29.58 MV. Option C, plus 59.16 MV. Option D, minus 118.32 MV. Time's up. The correct answer is A, minus 59.16 MV. Question 67. Forster resonance energy transfer, FRET, efficiency E between a donor-acceptor pair depends on their separation r as E equals r/r plus r, where r is the Forster radius. FRET is most sensitive as a molecular ruler in the distance range. Option A, 0.1 to 1 nanometers, sub-angstrom regime. Option B, 1 to 10 nanometers, comparable to R, typically 2 to 8 nanometers for fluorescent dye pairs. Option C, 10 to 100 nanometers, plasmonic near-field regime. Option D, 100 nm, 1 μm, diffraction-limited regime. Time's up. The correct answer is B, 1 to 10 nanometers, comparable to R, typically 2 to 8 nanometers for fluorescent dye pairs. Question 68. The CRISPR-Cas9 system requires a guide RNA with a 20nt spacer sequence complementary to the target DNA, adjacent to a PAM sequence, 5NGG3 for SP-Cas9. DNA cleavage by Cas9 occurs at a position. Option A, 10 BP upstream of the PAM sequence. Option B, 3 BP upstream of the PAM within the protospacer, between positions 17 and 18. Option C, exactly at the PAM sequence itself. Option D, 5 BP downstream of the PAM within the adjacent genomic sequence. Time's up. The correct answer is B, 3 BP upstream of the PAM within the protospacer, between positions 17 and 18. Question 69. The spliceosome assembles on pre-mRNA via ordered association of USNR and PS. The catalytic steps of splicing involve 2 consecutive transesterification reactions. In the second step, the 3O of the upstream exon attacks the Option A, branch point adenosine 2O in the lariat intermediate. Option B, phosphodiester bond at the 3' splice site, joining the 2 exons and releasing the lariat intron. Option C, 5' of the mRNA to initiate exon ligation. Option D, poly-A signal to terminate transcription. Time's up. The correct answer is B, phosphodiester bond at the 3' splice site, joining the 2 exons and releasing the lariat intron. Question 70. This sector 61 translocon in the endoplasmic reticulum membrane allows co-translational insertion of transmembrane helices. Signal anchor sequences are distinguished from cleavable signal peptides by Option A, the presence of a signal peptidase cleavage site following a hydrophobic core. Option B, the absence of a signal peptidase cleavage site, the hydrophobic segment remains as a TM anchor. Option C, their N-terminal location versus internal location in the polypeptide. Option D, their binding to SRP54 subunit rather than the SRP9/14 subunit. Time's up. The correct answer is B, the absence of a signal peptidase cleavage site, the hydrophobic segment remains as a TM anchor. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 71. The unfolded protein response, UPR, in the ER is activated by accumulation of misfolded proteins and involves three primary signaling branches, IR1 alpha, PERK, and ATF6. The IR1 alpha branch splices the mRNA encoding XBP1 via a non-conventional cytoplasmic splicing mechanism that removes a 26NT intron, creating a frameshift that produces Option A, XBP1S, a potent transcriptional activator of UPR target genes. Option B, XBP1U, an unspliced form that acts as a dominant negative. Option C, a truncated XBP1 protein that activates the ARAD pathway. Option D, a MICR RNA that silences IR1 alpha in a negative feedback loop. Time's up. The correct answer is A, XBP1S, a potent transcriptional activator of UPR target genes. Question 72. In the canonical WNT signaling pathway, in the absence of WNT ligand, beta-catenin is continuously phosphorylated by a destruction complex and targeted for proteasomal degradation. The destruction complex consists of Option A, APC, axin, GSK3 beta, and CK1 alpha. Option B, frizzled, LRP5/6, disheveled, and GSK3 beta. Option C, axin, GSK3 beta, beta TRCP, and DVL. Option D, APC, beta TRCP, CK1 alpha, and mTOR. Time's up. The correct answer is A, APC, axin, GSK3 beta, and CK1 alpha. Question 73. The mitotic spindle assembly checkpoint, SAC, ensures all kinetochores are properly attached before anaphase. The wait anaphase signal is generated by unattached kinetochores producing the mitotic checkpoint complex, MCC, which inhibits the APC/C by sequestering its coactivator. Option A, CDC20, preventing APC/C CDC20 from ubiquitinating securin and cyclin B. Option B, CDH1, preventing degradation of geminin. Option C, MAD2, directly inhibiting separase cleavage of cohesin. Option D, BUBR1, directly phosphorylating and inactivating APC/C. Time's up. The correct answer is A, CDC20, preventing APC/C CDC20 from ubiquitinating securin and cyclin B. Question 74. The regulation of eukaryotic DNA replication ensures that origins fire only once per cell cycle. Re-replication is prevented by multiple mechanisms, including CDK-mediated phosphorylation of the pre-replicative complex, pre-RC, component CDT1, which Option A, prevents its nuclear import and targets it for SCF-mediated degradation. Option B, activates geminin to sequester CDT1 and block its loading activity. Option C, both prevents nuclear import/promotes degradation and is inhibited by geminin. Option D, directly inhibits MCM helicase loading onto chromatin. Time's up. The correct answer is C, both prevents nuclear import/promotes degradation and is inhibited by geminin. Question 75. The R-loop, RNA-DNA hybrid, structures that form during transcription can cause genomic instability. One key mechanism by which R-loops promote DNA damage involves Option A, direct cleavage of the ssDNA strand by the elongating RNA polymerase. Option B, exposure of the displaced ssDNA strand to AID/ApoBec-mediated deamination and nuclease attack. Option C, activation of ATR kinase by the RNA-DNA hybrid structure itself. Option D, inhibition of DNA repair by physically blocking access to the damaged site. Time's up. The correct answer is B, exposure of the displaced ssDNA strand to AID/ApoBec-mediated deamination and nuclease attack. Question 76. In the context of liquid-liquid phase separation, LLPS, in biology, membraneless organelles such as stress granules and P-bodies are formed by proteins containing intrinsically disordered regions, IDRs. The driving forces for LLPS include Option A, covalent disulfide bond formation between IDR-containing proteins. Option B, multivalent weak interactions, pi-pi, cation-pi, electrostatic, between low-complexity sequences. Option C, ADP-driven polymerization of IDR proteins into filamentous structures. Option D, hydrophobic collapse of folded domains into amyloid-like fibrils. Time's up. The correct answer is B, multivalent weak interactions, pi-pi, cation-pi, electrostatic, between low-complexity sequences. Question 77. The G-protein coupled receptor, GPCR, signaling cycle involves receptor activation, G-protein dissociation, and signal termination. Regulator of G-protein signaling, RGS, proteins accelerate signal termination by Option A, phosphorylating and desensitizing the activated GPCR. Option B, acting as GT-PASE accelerating proteins, GAPs, that stimulate G-alpha subunit GTP hydrolysis. Option C, competing with G-beta gamma for binding to G-alpha to prevent reassociation. Option D, activating phosphodiesterase to degrade the second messenger camp. Time's up. The correct answer is B, acting as GT-PASE accelerating proteins, GAPs, that stimulate G-alpha subunit GTP hydrolysis. Question 78. The principle of neutral theory of molecular evolution, proposed by Kimura, states that most molecular variation within and between species is Option A, driven by positive, Darwinian, selection favoring advantageous mutations. Option B, selectively neutral fixed by genetic drift rather than natural selection. Option C, maintained by balancing selection, heterozygote advantage. Option D, caused by purifying selection eliminating deleterious mutations. Time's up. The correct answer is B, selectively neutral fixed by genetic drift rather than natural selection. Question 79. In the Ca superscript 2 calmodulin-dependent kinase 2, CAMKII, system, autophosphorylation at THR286 after calmodulin binding creates a molecular memory by Option A, permanently activating CAMKII even after Ca superscript 2 levels return to baseline, autonomous activity. Option B, inhibiting calmodulin binding and shutting off CAMKII activity. Option C, targeting CAMKII for ubiquitin-mediated degradation. Option D, recruiting phosphatase PP2A to reset the kinase to baseline. Time's up. The correct answer is A, permanently activating CAMKII even after Ca superscript 2 levels return to baseline, autonomous activity. Question 80. The Notch signaling pathway is activated by ligand binding, leading to 2 sequential proteolytic cleavages of Notch. The second cleavage, performed by the gamma secretase complex within the transmembrane domain, releases the Notch intracellular domain, NICD, which then Option A, directly phosphorylates and activates MAPK in the cytoplasm. Option B, translocates to the nucleus and converts CSL/RBPJ kappa from a transcriptional repressor to an activator. Option C, binds to and activates the HES1 promoter directly without a cofactor. Option D, triggers PTEN degradation to activate the PI3K/ANITE pathway. Time's up. The correct answer is B, translocates to the nucleus and converts CSL/RBPJ kappa from a transcriptional repressor to an activator. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 81. The molecular clock hypothesis assumes that DNA or protein sequences evolve at a constant rate. This hypothesis is often violated in practice due to Option A, differences in generation time, metabolic rate, and effective population size between lineages. Option B, the fact that all mutations are subject to positive natural selection. Option C, the recombination rate between loci being perfectly correlated with substitution rate. Option D, transposable element activity always accelerating molecular evolution. Time's up. The correct answer is A, differences in generation time, metabolic rate, and effective population size between lineages. Question 82. In the context of RNA interference, Dicer processes dsRNA or pre-mRNA into small RNA duplexes of 21-23 nt. The guide strand is loaded into RISC, RNA-induced silencing complex. Strand selection, guide versus passenger, is primarily determined by Option A, the sequence complementarity to the mRNA target. The more complementary strand becomes the guide. Option B, the relative thermodynamic stability of the 5 ends of the duplex. The strand with the less stable 5 end is preferentially selected as guide. Option C, the methylation status of the 5 end of the duplex strands. Option D, the length of the 3 overhang generated by Dicer cleavage. Time's up. The correct answer is B, the relative thermodynamic stability of the 5 ends of the duplex. The strand with the less stable 5 end is preferentially selected as guide. Question 83. The concept of epistasis in genetics describes interactions between loci. Synthetic lethality, where loss of either of 2 genes individually is viable but combined loss is lethal, is a form of Option A, positive epistasis, where fitness effects are more beneficial than additive. Option B, negative epistasis, synthetic lethality is an extreme form, where double mutants are less fit than expected. Option C, dominance, where one allele masks the phenotype of another at the same locus. Option D, pleiotropy where one gene affects multiple phenotypic traits simultaneously. Time's up. The correct answer is B, negative epistasis. Synthetic lethality is an extreme form, where double mutants are less fit than expected. Question 84. The phosphatidylinositol 3 kinase, Pi3K/anite/mTOR signaling axis is central to growth and survival. The tumor suppressor PTEN opposes Pi3K signaling by Option A, directly binding and inhibiting anite kinase activity. Option B, acting as a phosphatase that dephosphorylates PIP3 back to PIP2, depleting the anite activating lipid. Option C, activating the TSC1/TSC2 complex to inhibit RAB and mTORC1. Option D, inhibiting the mTORC2 complex that phosphorylates anite at SER473. Time's up. The correct answer is B, acting as a phosphatase that dephosphorylates PIP3 back to PIP2, depleting the anite activating lipid. Question 85. The prion hypothesis, proposed by Prusiner, 1982 Nobel Prize, states that prion diseases are caused by a misfolded isoform, PRPSC, of the normal cellular prion protein, PRPC. The key structural difference between PRPC and PRPSC is: Option A, PRPSC has additional disulfide bonds absent in PRPC. Option B, PRPC is predominantly alpha helical while PRPSC is predominantly beta sheet. Option C, PRPSC is glycosylated while PRPC lacks post-translational modifications. Option D, PRPC is a membrane protein while PRPSC is exclusively cytosolic. Time's up. The correct answer is B, PRPC is predominantly alpha helical while PRPSC is predominantly beta sheet. Question 86. In developmental biology, the concept of positional information was formalized by Wolpert using the French flag model. Morphogen gradients specify cell fate. The bicoid gradient in Drosophila embryos is established by Option A, active transport of bicoid protein from the posterior pole. Option B, localized translation of bicoid mRNA at the anterior pole and diffusion of the protein posteriorly with degradation. Option C, transcription of the bicoid gene from nuclei at the anterior pole only. Option D, a Turing reaction diffusion mechanism between bicoid and nanus proteins. Time's up. The correct answer is B, localized translation of bicoid mRNA at the anterior pole and diffusion of the protein posteriorly with degradation. Question 87. The concept of quorum sensing in bacteria involves population density-dependent gene regulation mediated by small diffusible molecules, autoinducers. In gram-negative bacteria, the prototypical autoinducer is A. Option A, peptide pheromone processed from a larger precursor. Option B, N-acyl homosaccharine lactone, AL, synthesized by Luxi-type synthases. Option C, cyclic DGMP signaling molecule that activates biofilm formation. Option D, oligopeptide that is transported intracellularly to bind cytoplasmic receptors. Time's up. The correct answer is B, N-acyl homosarin lactone, AL, synthesized by Luxi-type synthases. Question 88. The DNA damage response, DDR, to double-strand breaks, DSBs, activates two major kinases, ATM and ATR. ATM is primarily activated by DSBs and responds to the mRN complex, MRE11-Rad50-NBS1, that binds the break ends. ATM phosphorylates histone H2AX at SER139, gamma H2AX, which serves as a platform to recruit. Option A, BRCA2 directly to load Rad51 onto single-stranded DNA. Option B, MDC1, which amplifies the gamma H2AX signal by recruiting additional ATM and RNF8/RNF168E3 ligases. Option C, P53 directly to induce transcription of P21. Option D, CHEK1 kinase to phosphorylate and activate CDC25A. Time's up. The correct answer is B, MDC1, which amplifies the gamma H2AX signal by recruiting additional ATM and RNF8/RNF168E3 ligases. Question 89. The mechanism of auxin, IAA, action in plants involves the Tier 1/AFBF box receptors. In the presence of auxin, Tier 1 acts as a co-receptor. Auxin acts as a molecular glue that stabilizes the interaction between Tier 1 and its substrates, the auxiliary/IAA transcriptional repressors, leading to their ubiquitination by the SCF-Tier 1 complex and proteasomal degradation. This relieves repression of Option A, ARF, auxin response factor, transcription factors, allowing activation of auxin-responsive genes. Option B, PIN efflux carriers, causing increased auxin accumulation. Option C, AXR1, preventing netylation and activation of the SCF complex. Option D, ABP1, preventing cell expansion responses. Time's up. The correct answer is A, ARF, auxin response factor, transcription factors, allowing activation of auxin-responsive genes. Question 90. Bacteriophage lambda makes a lytic versus lysogenic decision based on integration of multiple signals. The key regulatory circuit involves a BIST-able switch between CI, lambda repressor, and CRO proteins. In the lysogenic state, Option A, CI repressor maintains its own expression from PRM while repressing lytic genes by binding OR1 and OR2. Option B, CRO protein represses CI expression, locking the phage in the lytic cycle. Option C, the CI repressor autocleaves in response to SOS signals, immediately inducing the lytic cycle. Option D, integration of lambda DNA into the host chromosome is required before CI can be expressed. Time's up. The correct answer is A, CI repressor maintains its own expression from PRM while repressing lytic genes by binding OR1 and OR2. Hey everyone! If you are enjoying the game so far, please smash that like button, subscribe to the channel, and drop a comment below. Your support means the absolute world to us and helps us keep making amazing content like this. Thank you so much. Now, back to the game. Question 91. The concept of genomic imprinting in mammals refers to genes that are expressed in a parent-of-origin specific manner. The primary mechanism establishing imprints involves Option A, DNA methylation at imprinting control regions, ICRs, set differentially in the male versus female germline. Option B, histone acetylation differences at promoters established during meiosis. Option C, antisense RNA transcription that silences the gene on one parental chromosome. Option D, transposable element insertions near imprinted genes that differ between sperm and egg. Time's up. The correct answer is A, DNA methylation at imprinting control regions, ICRs, set differentially in the male versus female germline. Question 92. In the mitochondrial respiratory chain, the proton motive force, delta P, across the inner mitochondrial membrane has two components, the membrane potential, delta psi m, and the pH gradient, delta pH. At physiological conditions, the relative contributions are approximately: Option A, delta psi m 150 to 180 mV, dominant, and delta pH 0.5 to 1 pH unit, minor contributor. Option B, delta psi m 60 mV and delta pH 2 pH units, each contributing 50%. Option C, delta psi m 120 mV and delta pH 2 pH units, roughly equal contributions. Option D, delta pH dominates with delta psi m being negligible in actively respiring mitochondria. Time's up. The correct answer is A, delta psi m 150 to 180 mV, dominant, and delta pH 0.5 to 1 pH unit, minor contributor. Question 93. The concept of synthetic lethality has been exploited therapeutically. PARP inhibitors, example olaparib, selectively kill tumor cells with BRCA1/2 mutations because: Option A, PARP trapping at SSBs in BRCA deficient cells leads to replication fork collapse that cannot be repaired by HR, causing DSBs and cell death. Option B, PARP inhibition directly activates the apoptotic pathway in BRCA mutant cells. Option C, PARP is required for NHEJ, which is the only DSB repair pathway in BRCA mutant cells. Option D, BRCA1/2 mutations cause upregulation of PARP that becomes the cell's sole survival mechanism. Time's up. The correct answer is A, PARP trapping at SSBs in BRCA deficient cells leads to replication fork collapse that cannot be repaired by HR, causing DSBs and cell death. Question 94. Voltage-gated sodium channels, NAV, underlie action potential initiation and propagation. Fast inactivation of NAV channels occurs within milliseconds of opening and involves: Option A, collapse of the activation gate, S4 helix returning to the resting position. Option B, physical occlusion of the cytoplasmic mouth of the pore by the inactivation particle, IFM motif of the 3,4 linker. Option C, phosphorylation of the channel by CAMKII in the I2 linker region. Option D, binding of beta subunits to the extracellular loops of the channel. Time's up. The correct answer is B, physical occlusion of the cytoplasmic mouth of the pore by the inactivation particle, IFM motif of the 3,4 linker. Question 95. The phenomenon of alternative splicing generates proteome diversity from a limited number of genes. Exon skipping, the most common form of alternative splicing, is regulated by the relative binding of splicing enhancer proteins, SR proteins, and silencer proteins, HNRNPS, 2. Option A, exonic splicing enhancers, SAs, and exonic splicing silencers, Ss, within the regulated exon. Option B, the polypyrimidine tract upstream of the regulated exon's 3' site. Option C, the 5-cap and poly-A tail of the pre-mRNA to control nuclear export. Option D, intronic splicing enhancers exclusively, with no role for exonic regulatory sequences. Time's up. The correct answer is A, exonic splicing enhancers, SAs, and exonic splicing silencers, Ss, within the regulated exon. Question 96. The concept of immunological synapse describes the organized interface between a T cell and an antigen-presenting cell. The bullseye pattern of the mature immunological synapse has the T cell receptor, TCR, complex concentrated in the central supramolecular activation cluster, CSMAC, surrounded by Option A, LFA1/ICAM1 adhesion pairs in the peripheral SMAC, PSMAC. Option B, CD45 phosphatase enrichment in the PSMAC to amplify TCR signaling. Option C, inhibitory receptors, PD1, CTLA4, exclusively in the PSMAC. Option D, MHC peptide complexes redistributed to the PSMAC after TCR engagement. Time's up. The correct answer is A, LFA1/ICAM1 adhesion pairs in the peripheral SMAC, PSMAC. Question 97. In plant immunity, the effector-triggered immunity, ETI, is mediated by NLR, nucleotide-binding leucine-rich repeat, receptors that detect pathogen effectors. The GARD hypothesis proposes that NLR proteins monitor, guard, host proteins that are virulence targets of pathogen effectors. The key advantage of this strategy is Option A, it allows the plant to recognize any effector that modifies the guarded host target, even novel effectors not previously encountered by the plant. Option B, it allows direct detection of the effector protein sequence by the NLR receptor. Option C, it eliminates the evolutionary arms race between host and pathogen. Option D, it provides systemic acquired resistance, SAR, throughout the entire plant. Time's up. The correct answer is A, it allows the plant to recognize any effector that modifies the guarded host target, even novel effectors not previously encountered by the plant. Question 98. The telomere length maintenance by telomerase involves the reverse transcriptase TERT and the RNA template component TR/TERC. The RNA template contains the sequence 3A-AAC5, in humans, that is used to extend the G-rich strand. The lagging strand gap problem, incomplete replication of chromosome ends, means that without telomerase, telomeres shorten by approximately Option A, 50 to 200 bp per cell division, corresponding to the length of the terminal Okazaki fragment and primer. Option B, the full length of the telomere in a single division. Option C, 3 to 5 bp per division, equivalent to the average mutation rate. Option D, 500, 1000 bp per division, corresponding to the distance between replication origins. Time's up. The correct answer is A, 50 to 200 bp per cell division, corresponding to the length of the terminal Okazaki fragment and primer. Question 99. The phenomenon of co-translational protein folding in bacteria is assisted by the ribosome-associated chaperone trigger factor, TF. TF binds to newly synthesized polypeptides emerging from the exit tunnel and delays aggregation. The primary driving force for TF binding to the ribosome is its interaction with Option A, the nascent polypeptide chain through hydrophobic contacts. Option B, ribosomal proteins ul-23 and ul-29 at the ribosome exit tunnel via TF's ribosome binding domain. Option C, 16 srRNA sequences near the peptidyl transferase center. Option D, the signal recognition particle, SRP, binding site on the ribosome. Time's up. The correct answer is B, ribosomal proteins ul-23 and ul-29 at the ribosome exit tunnel via TF's ribosome binding domain. Incredible! That's all 99 questions. The show is complete. Thank you all for watching Brain Burst. See you next time.